Okay, so this is 1732 here, and we're given this cart, and a force of P, 300 newtons is applied here. And what we're looking to find, we are given the center of gravity and its location here. And we're looking to find what is the normal force at A, normal force at B, and the acceleration that the cart is moving horizontally. And we're given that this mass of this cart is 60 kilograms as well. All right, so a lot of people want to do this problem as a static problem, and it is not a static problem because this cart's moving. The normal forces on an N and NA and NB are not going to be equal, so it's accelerating here. So these forces are going to be different. So do not solve this doing static analysis. So let's first take the sum of the forces in the x direction, and we'll set those to the mass times the acceleration in the x direction. All right, so the forces in the x direction, we have this negative 300 cosine of 30 degrees. All right, that would be the projection of this in the x direction. And then the mass of that is 60 kilograms, and then AX. So we get AX is equal to negative 4.33 meters per second squared, and that is equal to 4.33 meters per second squared to the left. Right, so that's one of our answers for this problem. Okay, now let's go ahead and sum the forces in the y direction and set those equal to the mass times the acceleration in the y direction. And we know that it's not lifting off the ground here, so this is 0. The acceleration in the y direction is 0. So we have the sum of the forces in the y direction equals 0. And we have NA plus NB, those two going upwards. And then we have P, the component of that, which is P sine 30 degrees. And then we have the mass of the object, the weight of the object, 60 kilograms times 9.81, and now it's downward, and that should be equal to 0. Okay. So simplifying this a little bit more, we know what P is here, 300 newtons. We can sub that in. So we have NA plus NB is equal to 438.6 newtons. Okay, the summation of both of those. So how do we figure this out? How do we see how much of this force is on A and how much is on B? Well, we can sum the moments around the center of gravity, and we'll call counterclockwise positive. And remember, that is going to be equal to 0. The sum of the moments around the center of gravity is going to be equal to 0. And we have our center of gravity right here. So let's go ahead and do that. So NA is going to create a clockwise moment, which is going to be negative. So that would be a negative moment. And the distance it's acting away is 0.3. So we have negative NA times 0.3. And let's look at NB now. NB is going to create a positive moment, a clockwise moment around G, and that is 0.2 away. So we have plus NB times 0.2. All right. And we're going to have both, for P here, we're going to have a horizontal component to this and a vertical component. So the horizontal component is going to create a counterclockwise moment around G. So that will be positive. And the vertical component here will create a clockwise moment, which will be negative. Okay, so let's do that. So we have 300 plus 300 cosine 30 degrees. So that's going to be the horizontal component. And the distance that it's acting away is 0.1, because that's 0.4 minus 0.3. So that's 0.1. And then we have the vertical component, which is going to be a negative moment, which is 300 sine 30. And the distance that acts away is 0.3 plus 0.08, because that's that vertical force right here. So that's 0.38. And that's going to be equal to 0. Okay? So using this equation and this equation, solving these simultaneously, we get NA is equal to 113 newtons, and NB is equal to 325 newtons. Okay, and that is the solution to 1732.